Comparing histograms can help us compare distributional information about two different populations. So in general, we'll often overlay one graph on top of another in order to visually compare two populations in some way. And first, we're going to look at what happens when you overlay histograms. Here I've loaded a classic statistics dataset, the one called Galton.csv, distributed with the course textbook. And here I've selected just 3 columns. Each row is describing some person, and that person's height appears in the child column. Now this person is an adult, not a child, so maybe that's not the best label for this column. But the reason we call them child is because we also have the heights in inches for their mother and father. And this data set was collected by a statistician named Sir Francis Galton, who had a large hand in developing the prediction methods that we use today in the modern field of statistics. This data set has 928 plus another 6 is 934 rows for 934 different people. Now, many of these people are siblings, so the reason why we see father and mother heights the same 4 times in a row is that this is all one family. They've measured the heights of 4 different adult children, and 2 happen to have the same height. But these don't just happen to have the same height, these are really the same parents of these 2 different children. So let's first take a look at the distribution of father heights. So the table is called height, and I can draw a histogram of a particular column just by writing down the column's label. If I want, I can annotate the histogram with units. So here we say percent per inch, because I said this was in inches, and the father's height in inches, split into 10 bins arbitrarily. So fathers range mostly from the height of around 64 to the height around 75, with a few outliers, and the vast majority of them are here concentrated in the range 67 to maybe 72. Now, one tricky thing about this data set is that each father entry is really for a child. So fathers that were very productive and had many children will be represented multiple times, and that skews the data set a little bit. But we still get a sense of how tall fathers are from this histogram. And we can also look at the height of children with the same expression, just by writing child here. And wow, the distribution looks quite different. Instead of most of the values being concentrated in the range 67 to 72, there are many in this range from 61 or so through 65. Also, instead of having a nice peaked shape, it has this kind of bumpy shape. Now this bumpy shape is something you'd notice regardless of how you drew the histogram. But the fact that the values are concentrated in a different range might not be obvious if you just looked at this histogram after that one. So the point of overlaying them is that we can see both histograms on the same horizontal axis. To do so, we draw a hist just like before, but we don't specify what column we want to draw a histogram of. And if you don't specify, then it will draw histograms of all the columns on one overlaid graph. So I'm still going to say the units are inches. This time I'm going to set the bins. I could have done that before. I don't have to do it, but it certainly is convenient to have bins that end at particular inches. So here I've created a bunch of bins that are 2 inches wide, and I see 3 different histograms for the 3 different columns in the table: the father, the mother, and the child column. So the father histogram that we drew before is here again in dark blue. The child histogram that we drew before is here in light blue. It has a slightly different shape just because we chose different bins. And now we see some new information, the mother histogram, which is offset from the father histogram. In general, males are taller than females among humans. And so we see a higher concentration of heights for fathers in this range around 70, and a higher concentration of heights around mothers in this area around 65. And what about the children? Well, the whole thing is just less high. It's a nice shallow mound instead of a peaked mountain. Why is that? It's not because children are shorter than adults. These are measurements of adult children. Instead, what this is showing is that the heights of children are not as concentrated in a narrow range. Instead, they're distributed more widely across this wide range all the way from 60 to 75. And why is that? Well, some of these children are males, some of these children are females, and so we're mixing together two different distributions that have peaks at different places, and what we end up with is a flatter distribution, meaning there's no particular high density area in the distribution. So to review, the syntax for creating an overlaid histogram is to create a table with columns for all the histograms you want to draw, and then you write .hist, and any options that you want to use to specify what the histogram looks like will be applied to all three of them. All three are using the same bins, the same units, and the fact that there are three is just because there were three columns in the table in the first place.